Okay guys, in this section 5-2 our topic is coterminal angles, and our objective for this section is to get an understanding of what coterminal angles are and how to determine an angle that would be coterminal to a given angle. And so just to kind of reiterate the different parts to an angle, you've got a vertex. Okay, you've got an initial side where you start measuring the angle from, and then a terminal side where the angle stops. And so a couple of other things to look at. So again, you've got an initial side, you've got a terminal side. We talked about the vertex of the angle. Now, if the initial side happens to coincide with the positive x-axis, then that angle is considered to be in standard position, right? So an angle that's in standard position is where the initial side of the angle coincides with the x-axis. All right. Also, positive angles are generated by a clockwise or counterclockwise rotation, and negative angles are generated by a clockwise rotation. So I kind of got that backwards. Let me make sure I say that again. Okay, so positive angles are a counterclockwise rotation, and negative angles are a clockwise rotation. All right, so keep that in mind. The way we label the angles is a lot of times in Precal you'll see them labeled with Greek letters, right? Or you can see them labeled with these uppercase letters, kind of like how they were when you took geometry. The angle could be labeled by the capital letter of the point of its vertex. Okay, so either of those, you'll see those notations. And let's see. Now, let's talk about the definition of coterminal. Okay. All right. So if you've got two angles that have the same initial and terminal side, then those angles are called coterminal, right? And so, like for example, when we look at this one, okay? So this angle alpha right here, all right? So the initial side is here, all right? And the terminal side is here, and let's just say that angle is 225 degrees, all right? Well, this angle beta, right, has an initial side here and a terminal side here, right? So let's just say that's negative 135 degrees. All right. These two angles have the same initial side and they have the same terminal side. So since that's the case, these two angles would be called coterminal. If they have the same initial and the same terminal sides, then they are coterminal. So 225 degrees and negative 135 degrees would be two angles that would be considered coterminal. All right. And here's another example. All right. So this angle from here to here looks like that it may be roughly what, 45 degrees, let's say. All right. And this angle from here around to here, right, is actually more than 360. It'd be what, 360 plus 45, and so 360 plus 45 would be what, 405 degrees. Okay. So those two angles would also be coterminal because they've got the same initial and they've got the same terminal sides. All right. So that just kind of gives you an idea of the how that you kind of see what coterminal. Okay. And so the next thing they give us is, we just looked at two examples of coterminal angles in degrees. So now they give us two examples of coterminal angles in radians. And so 0 radians and 2 pi radians are coterminal, okay, because they have the same starting and ending sides. As a matter of fact, 0 and 2 pi, the initial side coincides with the terminal side, right? Okay, because 0 is 0 degrees or 0 radians, and 2 pi is all the way around. So they end up having the same side, initial and terminal side. Okay, also these angles, pi over 6 and 13 pi over 6, right? Those two angles have the same initial and terminal sides. Okay? Now, if you're given an angle, how can you find an angle that's coterminal to it? Okay? So here's the key part here. You can find an angle that is coterminal to a given angle by adding or subtracting 2 pi. Okay? 1 revolution, right? And so if you want to add or subtract a full revolution to an angle, then that will give you another angle that's coterminal to it. Okay? And this actually works in degrees or radians. So if you're in radians and you want to find another radian measure that's coterminal, add or subtract 2 pi. All right? If you want to, if you have a degree measure and you want to find another angle that's coterminal to it in degrees, you would add or subtract by 360. All right? And as a matter of fact, you can also add or subtract by as many multiples of 2 pi or 360 as you want. Okay? So, for example, like if I take this pi over 6 and I add 2 pi to it, that gives me 13 pi over 6. If I take 13 pi over 6 and add another 2 pi, in other words, I go around again, that would be another angle that's coterminal with it. And if I added another 2 pi to that, that would be a third angle that's coterminal to it, and so on and so forth. So really, what we're getting at here is any angle has infinitely many coterminal angles because you can just keep going around in the circle as many times as you want. Okay? So really, like if I have pi over 6, okay, it would be coterminal with any angle that's pi over 6 plus 2 pi times n. In other words, the n is how many times you go around the circle. And so, again, if you plug in 1 for n, that would be 1 more time around the circle. If you plug in 2, that'd be 2 more times around the circle, 3, and so on. You can even plug a negative number in here, go the other way, and get multiple coterminal angles. Okay? So every time you go a complete revolution around the circle and stop at the same point to measure another angle, that is another coterminal angle. So you can go round and round as many times as you want and get infinitely many coterminal angles. Anytime you add another 2 pi to the measure, the angle measure, that's another coterminal angle. Anytime you add or subtract 360 to a degree measure, that's another coterminal angle, right? Because you can go around the circle as many times as you want. All right, so let's take a look at the first type of problem we're going to be looking at here from this section. All right? Okay, so it says for the positive angle, 13 pi over 6, subtract 2 pi to obtain a coterminal angle. All right, so they want to know what is the coterminal angle, right, that is can be obtained by subtracting 2 pi. Okay, so we'll start off with the angle, 13 pi over 6, and we want to subtract 2 pi to get another coterminal angle, And so what we need to do here first is, if I wanted to subtract these two values, then I should get a common denominator. And so I'll leave this as 13 pi over 6, but I'm going to change this to 12 pi over 6. So I'll need to multiply the top and the bottom by 6 to make a common denominator here. Now I can subtract the numerators and get pi and leave that over 6. So one coterminal angle to 13 pi over 6 is pi over 6. Okay? Let's see here. And so again, 13 pi over 6 is a little over one full revolution around the circle. So if I subtract 360 from that, right, pi over 2 from that, this would be the angle pi over 6. All right? Okay, let's see what the next one is that we have here. we've got 3 pi over 4. And we want to subtract again 2 pi to come up with a coterminal angle. So again, need to get a common denominator here. That's going to be 3 pi over 4 minus. So we probably should multiply top and the bottom by 4 here to get 8 pi over 4. Now we can subtract the numerators and get negative 5 pi over 4. Alright, so there you go. This would be an angle that's coterminal to 3 pi over 4. Alright, so what about this one? Let's say we have an angle that's negative 2 pi over 3. We want to add 2 pi to get another coterminal angle here. So once again, we do need to come up with common denominators, so that'd be 2 pi over 3 plus, let's multiply the top and the bottom by 3 to get 6 pi over 3. And now negative 2 pi plus 6 pi is 4 pi. Over 3. And then so that would be one angle that's coterminal to the other one. So when you look at this, negative 2 pi over 3 is going to be the negative angle, and then once you subtract, or once you add the 2 pi back to that, then you'll get positive 4 pi over 3, which is this angle from here to here. And then notice that they are coterminal, once again, because they have the same initial and they have the same terminal sides. Okay, so the next thing that we need to be able to accomplish from this section is to determine angles that are complementary or supplementary to each other. All right, and these, you probably learned about these two terms when you were taking geometry. Just remember, complementary angles, their sum is 180, and supplementary angles are two angles whose sum is 180. I think I may have said that wrong. Complementary are two angles whose sum is 90, and supplementary, two angles whose sum is 180. All right, so this diagram kind of shows complementary angles. If the two angles together add up to 90, they're complementary. And this diagram shows an example of supplementary angles. If it's two angles added together to 180 degrees, then they are going to be supplementary. All right? Now, let's take a look at these four examples. So let's start with example A. Okay, so if I have a degree measure that's 72, okay, we're trying to find the complement and the supplement of each angle. Okay, so if I have a degree measure that's 72, how would I find the complement? Well, I would need to go 90 minus 72, and its complement would be a degree measure of 18. Okay, so again, if you want to find, since complementary angles add up to 90, if you've got one and you want to find the other, just subtract that angle from 90, and what you're left with is the complement. And for 100, or for supplementary, you just do 180 instead of 90. So I do 180 minus 72, and I will get 108 for the supplementary angle to 72. Let's try B. Okay, so in B we're starting with 148, right? And so here's the thing that we want to make sure that that I might have glossed over here. It's two positive angles, right, that are supplementary, and two positive angles that are complementary. So positive is the key term here. Okay, complementary and supplementary angles don't involve negative angles. So like on this example, 148, okay, there is no complement to that angle. That is an angle that has no complement. Okay, why? Okay, so why doesn't it have a complement? Because it's already over 90. So the only way that you could get them to quote unquote add up to 90 is by subtracting. And of course, the angles have got to be positive; they can't be negative. So any angle that's over 90 degrees doesn't have a complement. This angle does, however, have a supplement. We can find it by doing 180 minus 1. Ooh, the second time that happened this lesson. 148, and we get 32. All right. So there we go. Now, these first two examples were finding the complement and the supplement in a degree measure. So now we've got to where we need to find the complement and the supplement in radian measure, right? So let's say I have an angle of 2 pi over 5 radians. Well, how would I find its complement? Well, first of all, let's make sure that this is not over 90, right? Okay, so 2 pi is 180. 2 pi is 360. Pi is 180. So pi over 2, right? So pi over 2 would be 90. So anything that's over pi over 2 is not going to have a complement, all right? And so this is 2 pi over 5, which is under pi over 2, so this one would have a complement. And so let's go pi over 2 minus 2 pi over 5. Because remember, in degrees, if it's 90 minus the angle, then in radians, it's 2 pi minus the angle. 90 degrees is 2 pi radians. So in order to perform this, I'll need to get a common denominator. Common denominator between 2 and 5 is going to be 10. So I'm going to change this denominator to 10 by multiplying by 5. So I'll get 5 pi over, lost my light. There we go. 5 pi over 2 minus, and I'll turn this denominator to 10 by multiplying by 2, 4 pi over 10. That's not 2, by the way. Messed that up. Let's make that 10. All right. So now we've got a common denominator. We can subtract the numerators. 5 pi minus 4 pi is pi, and that would be over 10. All right. So the angle that's complementary to 2 pi over 5 would be pi over 10. Let's go for supplementary now. And remember, in degrees, if you subtract the angle from 180, in radians, you're going to have to subtract that from pi, because 180 degrees is pi radian. So we'll go pi minus 2 pi over 5. Once again, I need to get a common denominator, which would be 5 here. So multiply the top and the bottom by 5. So that'd be 5 pi over 5. Minus, we've got what, 2 pi over 5 here. It's already in the common denominator. 2 pi over 5 equals 3 pi over 5. All right, so we've got one more to do here. And so for this one, we want to find the complement and supplement to this angle, 4 pi over 5 radians. Okay? So now, when we take a look and analyze 4 pi over 5 radians, if you convert that, remember, by multiplying by 180 over pi like we did in the last section, okay, so you will find that that is 144 degrees, right? And remember, pi is 180 degrees, so 4 pi over 5 is close to pi, right? And so it's definitely over 90, which means there's no complement. Okay, and if you had went ahead and subtracted that off from pi over 2, you would see that your answer would have been negative, and then that's your clue that there's no complement. So if you didn't catch that this angle was greater than 90, after you did the subtraction, you would end up with a negative angle, which would lead you to the conclusion that there's no complement, because once again, remember, complementary and supplementary angles have to be positive. Okay? All right, what about the next one? So for supplementary angle, which it does have, it'll be pi minus 4 pi over 5, right? And once again, we need a common denominator. We'll go 5 pi over 5 minus 4 pi, or excuse me, didn't write that correctly, 4 pi over 5. And we can subtract that off to get pi over 5. And then that would be your supplement. All right? And that's it.